Hi guys, back again with some more chapter 7, and looks like we're gonna do objectives 3, 4, maybe more. We'll see. We'll see. Without further ado, I am sharing my screen. Donde está? Okay, and we got through all this. So we're on objective 3, and we're gonna talk about some of the cortex areas involved in movement. Okay, so movement in the brain is accomplished mainly by these 3 areas, but there's going to be aspects of movement that are handled all over the brain. So movement is actually all over the brain, but primarily we're looking at these 3 particular areas when it comes to planning movement and carrying out movement, initiating it. So primary motor cortex, supplementary motor area, and premotor cortex. We've talked about primary motor cortex before. That's in the frontal lobe, toward the back of the frontal lobe, also known as the precentral gyrus. We'll talk about that first. As I said, known as the precentral gyrus, it has this little homunculus, meaning that different parts of the body are represented on it. It has the function of ordering complex activity patterns, for example, like talking, or walking over to something, picking up something. We do have contralateral control, so the left side of our brain is going to control movement in the right side of our body, and vice versa. It produces outcomes regardless of starting position. So if you're standing on your head and you go to pick up a cup, that may be different from standing on your feet going to pick up a cup, but it kind of accomplishes both of those. The starting position doesn't matter as much for this area. So mirror neurons are involved there as well. So we do see activities of mirror neurons, and those are neurons that become active when you move or by watching another person move. So if we watch someone doing a dance, for example, there's some mirror neurons in our precentral gyrus that start lighting up. And then when we go and perform that dance, then the mirror neurons will then again light up while we do the dance. So they light up when we're watching it, and they light up when we do it. And that seems to account for some observational kinds of learning things. Okay, we got a few other areas involved in movement here, as I mentioned. So one thing is the prefrontal cortex. Prefrontal cortex right out here in front of the brain in pink on this picture. And it is going to assess the probable outcome. It's kind of like, is this a good idea? You know what I mean? If you say you want to ski downhill or something like that, your body is going, is this a good idea, or am I going to get hurt or something like that? And if so, if you feel like it is dangerous, then your prefrontal cortex will sort of have an inhibitory function on that. The premotor cortex and the supplementary motor cortex are active when planning a movement. So they seem to be kind of getting us in the mode of a movement. They're not as active when you do the movement, but they are active right before you do the movement. And then finally, the posterior parietal, we've talked about before, that's our dorsal stream in vision. And it is involved in just kind of knowing where things are. And again, it's also involved in planning movement. But that has to do with the orientation of your body toward whatever object you're moving on. Okay, we're going to talk a little bit about how the spinal cord is involved in movement. We've got a couple of tracks down the spinal cord for movement. One is called the lateral corticospinal, and lateral, of course, means on the outside. So you can think of this because it's lateral, it's to the sides. This is your control of your fingers, your hands, your toes, all of your fine motor control out in your body, in the periphery of your body. And then there's the medial corticospinal, and these tracks go down the spine to control your trunk, your neck, your shoulders, everything's so kind of closer to the middle, therefore medial. In the medial corticospinal, there's no crossover of tracks, so we have what we call same side control or ipsilateral control. And then the lateral corticospinal has contralateral control, and you'll see that in the next slide here. Here you can see the first one here on the left is the lateral corticospinal tract, and you can see that crossover happening there right around that pons medulla area of the brain. And whereas in the corticospinal tract, you do not see the crossover happening there. So we do not have the contralateral control there. Well, if we get damage, I hope you figured out by now, to the corticospinal tract, the medial corticospinal tract, there you're going to end up having problems with posture and balance and things like that. Whereas if you get problems with the lateral corticospinal tract, you're going to have problems moving one side of your limbs, basically. Okay, we are going to discuss some of these other areas in the next video on Objective 5. We'll see you soon.